In Module 21, the last part of the quality control, we will see the non-destructive tests that can detect defects without destroying the structure. So let's see now the last part of the quality control on bonded structures, but this time non-destructive tests, all right? I don't want to destroy the structure, but I want to see if there is a defect. What's the first non-destructive test? Well, that's your eyes. Your eyes can already detect a lot of defective joints. You have here some of them. I have here also some specimens. I will show you. So this is a perfect one, all right? Perfect joint, a nice excess of adhesive with a nice shape, natural shape, no lack of adhesive on the edges. It all looks beautiful. Adhesive thickness well controlled, well aligned. You see, perfect joint. Now we have many times problems. For example, this one, can you see? There is a lack of adhesive. On this part, I think is clearer. There is not enough adhesive. We didn't put enough adhesive here, and the thickness of the adhesive is not uniform along the overlap. Here it's thicker than in here, it's thinner. So this is a defective joint, absolutely no doubt. This one, can you see the shape of the spew fillets? A very, very strange shape. Probably the viscosity was not right, the flow was not right, the wetting was not right. So this also does not look good. Then you have joints which there is a clear misalignment. It can be the adhesive thickness, but it can also be the alignment of the two substrates. I think this is more than obvious. So you can see your eyes can already detect a lot of defective joints. You don't need any more than your eyes. In that case, you need to fabricate again the joint. But of course, there is a more sophisticated ways to detect. One of the first non-destructive tests was the tap test. I'm sure you have done this at home to detect if there is adhesive or not in a joint. You just tap. If there is a sharp, clear tone, good sign, there is adhesive. If it's a dull, hollow tone, probably there is a lack of adhesive, a big void. You can do it with a hammer, with a coin, or you can instrument it and have something that is much more controllable. But the king of the non-destructive tests by very, very far is the ultrasonic method. Very, very easy, the method. You have a probe and you send ultrasonic waves to the joint. When there is a defect, you will have a clear reflection and this can be easily detected in the scan that you do to your joint, as indicated here. So you have a probe that will scan the whole joint, and then you will have an image of the bonded area, and defective parts will show very clearly. What kind of defects can you detect? Basically, you can detect everything. You have here examples of delamination, inclusion, porosity. This is also used a lot for composite materials to detect the defects in composites. The same applies in adhesive joints. What other non-destructive tests can you use? You can use radiography. It's good to detect voids and discontinuities. You have here the principle, you have the source of radiation, you send the radiation to your joint. When it encounters defects, this will appear as different colors in the image. You have here an example. This is a joint that is absolutely perfect, and this is a joint that has defects. Clearly you have here and here some delaminations. The contrast improves if you have metal powders or other suitable fillers in the adhesive. Then you have eddy current. Also, this is also a technique that is used for other contexts, other joints, and the same principle applies here. You use a magnetic field to induce currents in the joint, the eddy currents, and these eddy currents will change if you have defects, a big void, for example. Clearly the eddy current will be completely different. Thermal methods as well, they can be used. you heat your specimen. If there is a defect, for example, lack of adhesive, there will be, the heat transfer will be different. If you detect the temperature on the same side that you heat, a defective part will appear hotter. If you detect on the other part, it will appear cooler because of the heat conduction. This is quite straightforward. Now you have more sophisticated methods, for example, lump waves based on vibration at very, very, very high frequencies. If the specimen has defects, a porosity or void or whatever, the response in frequency will be different, and you can detect like these defects. EMIS, electromechanical impedance spectroscopy, very similar to lump waves, but the range of frequency is much broader, but that's basically the same principle.
In electromechanical impedance spectroscopy, or EMIS, we make use of an impedance analyzer here and of a piezoelectric element here that is bonded to a specimen or structure under evaluation. In this method, we excite the piezoelectric element with a electrical signal of various frequencies, and for each frequency, said signal will generate a mechanical vibration on the structure. Concurrently, the mechanical vibration will also influence the electrical signal passing through the piezoelectric element, and by measuring the electrical impedance of the sensor, we are indirectly measuring the mechanical integrity of the structure.
And I leave the last two for the tests that can detect in a way weak adhesion. I told you it's nearly impossible. There are two tests that can detect more or less the thing. The first is acoustic emission. So during the test, but you need to load the specimen, so it's not perfectly non-destructive. You need to load, and during the loading you will hear some sounds. So by picking these sounds, you can relate this to a weak adhesion, but you need to load it sometimes quite close to the failure load, so extremely dangerous non-destructive test. And the other one, it is more recent, it's a laser method. You send laser pulses to your joint. This will hit the joint and will generate ultrasonic responses. And these ultrasonic waves will be different if you have a weak adhesion. The problem is that you might, the laser pulses might be strong enough to disbond the parts where you have weak adhesion. So in fact, it can destroy your joint. So very, very dangerous method. But this is increasingly used in the aeronautical industry to detect weak adhesion. And that concludes the non-destructive tests, the test to detect defects without destroying the structure.